Hey class, this is Mr. Roberts, not at Shasta High School. I'm sitting in my garage, and I'm going to go through the, what did I call this? I said that this was a Chapter 3 test preview for 2014. So let's take a look at this. Our first question says that on these diagrams that you're given here, we're supposed to rotate these shapes 180 degrees about point Q. So I'm going 180. I'm going to mark off a couple things here. So one of the things I kind of like to do is I'm going to just extend this line, and I'm going to extend it this way. So I'm just drawing that line. And I know that when I rotate around this point Q, the very tip of this D is going to hit right here. And this top right here is going to be, it's going to be it's going to be from there, it's going to be down 1/2. I think it's going to go to here. So I think those two things are in green are going to line up after I rotate through 180. Okay, so then the rest of it, it's going to go back 4 units along here. So I'm just going to go 1, 2, 3, 4 units back. And then I'm going to have these, 3 units tall. And then I'm going to go 4 more units. Ooh. 1, 2, 3, 4. And then I'm going to have this up 2/2. So I think this is the last one right here. There we go. So this would be the shape D prime after rotating 180 degrees about the origin. That is, I mean, I definitely have patty paper available if you're doing a problem like this and you think it would be helpful to trace it and draw it. But I'm just trying to think about what happens when I rotate 90 degrees, opposite reciprocal slopes. Let's move to the next one. Oh, reflect across line L. So this is nice because I know that when I reflect across the line, the image points all have to be the same distance. So this is 2. So this is going to be the first point up here. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The other thing I can do is this is like over here, it's like down 1, or I can say up 1 over 1, 2, 3, 4. Down 1 over 1, 2, 3, 4. Yep, that's it. So if I was going to connect those, I might want to connect them with a straight line. So that's that. And then the last one here is just over 3 over 3. So from here to here, and then from here to here. And this is what I should get when I reflect this thing across line L. Obviously, some of the problems on the test may require that you go ahead and maybe identify the coordinates of points after these reflections. This one looks tough. Let's see. I'm going to go, whoops, I don't need that. It's going to be 1. So this is going to be 1 right here. So those points match. This is 1, 2, 1, 2. So I'm just counting these diagonals now. That's going to match. This is 1 and a half, and 1. That point's right there. Okay. And then this is 1, 2 full points, 1, 2 full points. Okay. So I think what I've got so far is this, and this. This is now going to go, what is it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ooh, that's crazy. I'm landing here. And then I have to go up 2. Okay. Then I have to do this one little diagonal here. And then finally, I think I'm just connecting these back together. So that's it. The big thing is just being able to, if I draw a line from this shape to here, I should always see that the lines that connect the original point to the image point should always be perpendicular to the line that I'm reflecting across. So those should always form right angles, which means they should have opposite reciprocal slopes. All right, that was C. And then finally B, it says take this thing and rotate it clockwise 90 degrees. Oh, around point P. Okay. So when I do that, this is going to just go here and lay down right there. And it was 1, 2, 3, 4, 5 tall. So it's going to be 1, 2, 3, 4, 5. Got it. And then this was 3 tall, so it'll be 3 tall. And then it was 3 this way. And then I'm calling this the nose. And then it's going to go back to here and to here. So if I was to take that original shape and rotate it 90 degrees around point P, that's where that would land. All right, moving right along. I have no ability to pause this recording. Okay. I hope I get it all right then. Next, find the slope of the given the following. So it's only asking for the slope for each of these. That's very pleasant. So for here, I don't know anything about the scale. I feel like you've really let me down, Mr. Roberts. So I'm just going to assume that 1 square equals 1 unit. I'm going to say the slope is 1, 2, 3, 4 down and 1, 2, 3 over. So it looks like my slope is negative 4/3, down 4 units over 3 units. The next one, it says, find the slope of the line that goes through these 2 points. Okay, I'm just going to take the 3 minus 7, and that will be over 6 minus negative 4. 3 minus 7 is negative 4, and that's going to be over positive 10, which reduces to negative 2/5. Negative 2/5. Next, I want the slope of a line that is perpendicular to this line. This line has a slope that is down 3/5. So a perpendicular line would have a slope that's opposite in sign and reciprocal. So it would be positive 5, 3. So this would be up 5/3 units. And if I was to come here, this is kind of fun to look at. So if I'm here, I can go from this point, I can go down 1, 2, 3 over 1, 2, 3, 4, 5. Okay, so if I was to connect those 2 points, I would have that line. But then if I said, okay, let's go and do the line that's perpendicular to that, I would just start at maybe this point, and I would go up 5, up 1, 2, 3, 4, 5 over 1, 2, 3. I don't know why, but I've always found this really compelling, that I have this ability to make right angles just anywhere by using this opposite reciprocal slope. So yeah, that's very convincingly a right angle. So it would have to be positive 5/3. Or just 5/3. Next, I want a slope that is parallel to this line. Of course, the question is, well, what is the slope of that line? So I'm going to transform that into slope-intercept form by subtracting 8x from both sides. So I'll have minus 4y is negative 8x plus 40, and then I'm going to divide everything by 4. So y equals negative 8 divided by negative 4x, and then this would be minus 10. So if I'm looking at this slope, this looks like it's a slope of positive 2, right? Negative 8 divided by 4 is positive 2, and because it's parallel, it would have the same slope. So I could say the slope is 2, or if you want, you could write up 2 over 1. Whoops. All right, moving on to question number 3. It says we've got this rule, x gets squared, and then we subtract 6, and we are asked to complete a table of values here. So I'm going to go ahead and use my calculator, and I'm not ashamed to admit it. So on this thing, if I hit table, it says, okay, enter the function. So I can say, look, I'm going to take x, and I'm going to square that, and then I'm going to subtract 6 from that, enter. And I'm going to make this say auto, but I'm going to make it start at -4, because that's where this table starts on the, so I'm going to say start at -4 and step by 1 unit at a time, and okay. So the first thing you can see is it tells me, well, when x is -4, I square that, I get 16. 16 minus 6 is 10. -3 squared is 9. 9 minus, what? 9 minus 6 is 3. This table is doing exactly what I want. -2 would give me -2. If I hit the down arrow here, doop, 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 I can see that 1 reports it's going to hit at -5. 0 is going to hit at -6. 1 is going to hit at -5. 2 is going to hit at, oops, let me go down a bit more. Oops, down, down. 2 is going to hit at -2. 3 is going to hit at 3. Really? Square that? Square that, I get 9 minus 3 is 3, yeah. And then 4 is going to take me back up to the number 10. All right, so I've got the values there represented, and I found those pretty nicely. That's a cool trick on this calculator, right? When you hit table, it allows you to enter the function. The function we're entering is x squared minus 6. And there's some features here, right? You can tell it where you want it to start. Right now it's going to start at -2, but you can tell it where to start and what to count by. Anyways, we're done with that, so we can move the calculator away and go ahead and plot these points. So it says, complete the table. I did it. Now plot the points and connect them on the graph at right. Okay, so I'm going to begin with -4 being up at +10. So I've got this spot here. Beautiful. The next spot I have is that -3 is going to 3. Okay. And then I've got -2 is going to -2. And negative. Oh, no, -2 is going to -2. -2 is going to -2. And -1 is hitting at -5. 0 is hitting at -6. And then I see some symmetry here, right? The 1 is going back to -5. The 2 is hitting at -2. The 3 is back up to 3. And then finally, the 4 is way up to 10. So beautiful. Not something we see often, but we will see this often, right? This is a nice parabola. And it says connect them and then draw trying to draw a curve that connects them. I think I could do better on paper. This electronic pen is not exactly what I want, but okay. I've evaluated a table. I've plotted the points, and now it says, is this a function? Oh, for sure. Yes. Why do I know that? Each domain value has at most one range value. Okay. Next, state the domain and range. Okay, for this function, the domain is all real numbers. Right? Literally any real number I could square and subtract 6 from. So I could do this for -6, -8, -100, -1,000,000. It just keeps going, and it's going to get taller and taller. It's going to get, it's going to stretch up more and more, but all the real values, or all reals, are in the domain. And then in terms of the range, I can see that there is a limit for the range. The smallest number that this hits is the number 6. So I'm going to say that the range is y values that are greater than or equal to -6. The one spot where it would equal -6 is when x was 0, but that's the minimum value, and anything else is more than that. All right, let's move on to question 4. It says, solve the following equation and show all necessary work. So this one, looking inside, the bases are equal, right? The bases are both 3. So I know that this exponent has to be equal to the other exponent. Therefore, n has to be 3/2, 3 over 2. And it seems kind of extra, but it seems kind of obvious that that's the answer. But if I'm at all concerned, right, a great strategy always is to go ahead and take your value, 3/2, and plug it into the equation. So on the one side, I've got 3 to the power of, open parentheses, 3/2. Are you serious, Roberts? 3/2? Yeah. And what are you going to do with that now? Multiply it by, oh no, it's 2 times, multiply it by 2. You do know that 3/2 times 2 is 3. Oh yeah, it is, huh? So it becomes 27. On the other side, 3 to the third. You're really typing that? I don't know. Yeah. 3/2 makes both sides 27. You're right. I should have known better. All right. What about this one here? Well, I can rewrite the number 4. 4 is 2 squared. So what I can do is I can rewrite the 4 as 2 to the second. So this thing right here is equivalent to that. They're totally equal to each other. That's a valid replacement for the number 4. That makes this side 2 raised to the 2x power. And on the other side, I got 2 to the 12. The only way that 2x, because the bases are both 2, the only way this is true is if 2x is equal to 12. Therefore, x must be the number 6. I apologize, but it appears a car is coming into the garage. So this is going to be loud for a minute. But then it'll get quiet, I promise. There it is. The CRV is turned off and it's quiet in the garage again. Let's continue. So x is equal to 6. And if I were to plug that into here, 4 to the 6th power should give me the exact same thing as 2 to the 12th. And I actually do want to check that. 4 to the power of 6. Oh, I got to grab this one. 4 to the power of 6 gives me that number. And if I look at 2 to the 12th power, I'm looking at exactly the same thing. Perfect. So x is 6. That's part B. I can't pause this video for some reason, so I'm just kind of keeping going through this. So no, I know, I understand. I gotcha. But I can't pause it right now, so I can't stop. Next question, C. It says, find the value of x here. When I look at this, I can see I've got a factor of 2, a factor of 3, a factor of x, and a factor of 2 again. So I know that multiplying through by 6 times x would clear all the fractions. 6 is beautiful. It contains a factor of both 2 and 3, and I need this factor of x. So what I'm doing in my mind mentally is I'm taking this 6x, and I'm going to multiply by here, 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 and here. And in each case, I'm going to divide by the denominator and then multiply by the numerator. So when I put 6x in this spot first, 6x divided by 2 is 3x. So I get this becomes 15x. Okay, you see the trick I'm playing. Now I'm going to do it right here. 6x divided by 3 is 2x. Times 1 would be plus 2x. On the other side, I've got 6x divided by x is 6. So this is going to make this one 60. And then finally this one, 6x divided by 2 is 3x. And 3x times 1 would be plus 3x. So this is 17x is 60 plus 3x. If I take away 3 x's from both sides, I got 14x is 60, and therefore x is 60/14, and I know that reduces. I can clearly divide by 2. That gives me 30/7. I think that's all I can do with that. So let me check that. I got 60 over the number 14, which reduces to 30/7. Great. Now I'm going to check that answer. I'm going to do so by taking this value and storing it as x. So at this point now my calculator believes that x is the number 30/7. If I was to press, hey, what's x, and press enter, it would say that number. So now I'm just going to plug it into the equation right here and make sure that it makes both the left and the right-hand side the same. So on the left-hand side, I've got 5/2, okay, and I'm adding to that 1/3, okay. When I add those together, I get a whopping 17/6. And on the other side, I have 10/x, and I'm going to add to that a half. Whoops. I add to that a half. Oh, I need to add a half. Can I put a plus? There we go. And when I add a half, I get exactly 17/16 or 17/6. So because this value makes both the left-hand side and the right-hand side the same, I know it is a solution. Both sides became 17/6. So the answer for part C is x is 30 divided by 7. And then the last question, okay. I'm going to do a rewrite on the left-hand side, and I'm just going to do this mentally. I'm not going to use a generic area model. So I've got 2x times x is 2x squared. Then I've got 2x times -3 is minus 6x. And then I'm going to jump to the 1. 1 times x is plus x, and 1 times -3 is -3. I can combine those like terms. So this is 2x squared minus 5x minus 3. On the other side, I've got x squared plus 12 plus x squared. Well, that's 2x squared. So, so when I combine the x squared and the x squared, and I subtract 2x squared from both sides, I have a very ridiculously simple linear equation. 5x minus 3 is 12. Therefore, I'm sorry, negative 5x is 15, and x should be -3. And pretty compelling that x is -3. I am going to check that. 3, I'm going to store that as x. And I'm going to take a quick look at 2x plus 1, 2x plus 1. And I'm going to multiply. Ooh, except I forgot to hit x. So that's 2x plus 1. And I'm going to multiply that times x minus 3. Whoops. Not being very good with this. X minus 3. And when I do that multiplication, this side becomes 0. Okay. Oh, yeah, it is 0 because 3 minus 3 is 0. On the other side, that's a problem. That's a problem. This answer is wrong. And you know why this answer is wrong? This answer is wrong because I didn't type in the right value. I was supposed to type in -3. So let me do that now. -3, oops, grab the right calculator. -3 is being stored as x. Boom, there we go. Now I'm going to grab this expression up above, and I'm going to grab it and ask it to evaluate that a second time. And this time it says it's the number 30. Okay, what's nice about that is it's believable. Over on the other side, I'm going to have x squared plus the number 12 plus an additional x squared. And when I do that, I get 30. Perfect. That means happiness can abound. It is the case that for D, x was a -3. Fabulous. Let's continue. I got to open the door for my dog here. Hey, buddy. Okay, come on. Hey, calm down. Come on in. Yes, you can be here if you want. All right, let's see. Number 5. It says, find the slope of segment AB. Well, that sounds like a nice thing. It's down 3/2. Looks like the slope of segment AB is negative 3/2. Great. Find the equation of a line through point C that is perpendicular to segment AB. Oh, okay. I gotcha. Well, so first of all, if it's perpendicular, the slope that I have to be using here is positive 2/3. Okay. And it has to go through this point. Well, this point is it's 3, 3. So we could just write the equation right now, right? Using point slope form. I could write the following. I could say, hey, y minus 3 is equal to 2/3 times the quantity of x minus 3. So that is the answer in point slope form. If I want, I can change it up. I'll add 3 to both sides. So this is going to be y is 2/3 times x. Let's see, 2/3 times negative 3 would be negative 2. And then plus 3 more. So it looks like the y-intercept is at 1. So if I wrote it in slope-intercept form, the equation's y equals 2/3 x plus 1. And I can confirm that by going, let's see, the slope was positive 2/3. So if I was to go down 2 and back 1, 2, 3, I can see, yeah, I would hit this, right? So this is the y-intercept, and you can see from here I can go up 2, over 1, 2, 3. Yeah, that's perfect. So that is the equation of a line that's perpendicular to AB, and it would go through C. And of course, if I grabbed a point, I'm going to say, hey, to start here and go through. Oh, what? Get out of here. There we go. Look at that. Amazing. Making a right angle right there. No troubles at all. All right, there's one more question here. It says, add the line you found in part B to the graph. What that? That's, I just did that. That's beautiful. Wonderful. And then that's it. That's that question. That's somehow not satisfying. All right, that's the end of that question. Let's move on to question number 6. 6. Multiply. Use an area model to organize your work. Simplify your answer by collecting like terms. Okay. So right now, if you think about this, what I have here is the area of a rectangle expressed as the length times width. But we're going to find the area of this rectangle expressed as a product, or as the sum of the parts. So let's go ahead and create an area model for that. So for this area model, I want to go 3 by 2. And I've got a 4x squared, a 2x, and a negative 3. And right here, I've got an x and a plus 6. So I'm going to multiply the dimensions of each of these rectangles to find the area of the individual pieces. And then if possible, we'll combine like terms to simplify. So the first box right here is 5x squared. Below that, I have, not 5x squared. X squared times x is 5x cubed. Below that, I have I have 24x to the second power. Next column over, I've got 2x times x, which is 2x squared, better. Didn't make a mistake yet. Then I got 2x times 6, which is plus 12x. Okay. Next column over, I've got negative 3x, and then below that, I've got negative 18. So I take a look at this. There are a couple things I can clearly combine as like terms, right? These are like terms, and furthermore, these are like terms. So I can go ahead and collect those up. So my answer looks like this is going to, I'm going to say this equals, right? Length times width is equal to 5x cubed plus 26x squared plus 9x, and then minus the number 18. Fabulous. Next problem. Oh my gosh, I don't need an area model for that. Totally do not. I'm going to do it anyways. So let's see. I got an x, I got a negative 4. I'm going to be multiplying that by 3x and then 1. If I fill in the parts here, I've got 3x to the second power. Below that, I've got an x. Next column over, I've got negative 12x. And then below that, I have a negative 4. So when I multiply that length times this width, it equals 3x squared minus 11x minus 4. Yes, I definitely combined the x and the negative 12x to get negative 11x. All right, one more of these. Definitely not using an area model here. This is just a binomial times a monomial. When I multiply 3x times negative 2x, that's negative 6x squared. And then when I multiply 1 times negative 2x, I just get negative 2x. So that is that product. So anyways, that's the product expressed as the sum of the parts, the sum of the parts, the sum of the parts. And I think when I write your test, I should make it clear that to put those lines somewhere else. All right, let's move on. Let's see. The following was created with x squared, x, and unit algebra tiles. What is the perimeter of this shape? Oh, okay, perimeter. So I know that the x squared tiles are x by x. So this is x long, that's x long. This is an x. X tiles are 1 by x. So this is a 1, a 1, a 1, a 1, a 1. This is 1. Now I got my first interesting piece. This piece right here is an x tile, but from it, 2 was subtracted. So this green segment is x minus 2. This is 1 unit. This is 1 unit. This is x, 1, 1. Another interesting piece. This piece right here, I'll highlight in blue. That blue segment right there is x minus 1. It's x minus 1. And then I've got a 1, a 1, a 1, a 1, and a 1. Okay, so if I take a look at this, I got many x's, right? If I just count them, I can see I've got 1, 2, 3. I'll just count these two. 4, 5, 6, right? 1, 2, 3, 4, 5, 6 x's. Okay, so we have 6x. And now we got to count up our units. So units, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right, so part of it is there is 15, but also I have these negative ones, right? I got a negative 2 and a negative 1. So it's going to be 15 minus 3, which is 12. So the final perimeter will be 6x minus 12 units. So 6x minus 12 units. And that's it. That is it for this small test preview, right? Because again, the questions that I'm sorry that I hit it. I'm sorry. I did not realize that calculator was on the entire time. I didn't see that, which probably means that there are things you couldn't see. I'm sorry about that. But anyways, this test preview is a collection of, the types of problems that you could see on the test. The questions that you saw on Primetime Monkey, right, on the game last Friday, good place to look for other possible types of questions. And the test is this Thursday in class. Hope you found this helpful. This is Mr. Roberts. Talk to you later.